Alright, so 3.2, we've got negative 5x squared minus 60x minus 100. And here, if we apply our sort of hierarchy of factorization, if you can call it that, and starting, they call it the golden rules of factorization, I will again go and see if I'm able to take out a highest common factor first. So looking at this trinomial, because this is a trinomial, there's 3 terms, 1, 2, 3, and this again is a good example of you identifying that this has the form of a trinomial, but you don't necessarily have to, or you shouldn't necessarily jump straight to number 3, because the golden rule says that we need to check first if there's a highest common factor. And is there one? If you look at these 3 terms, it seems like there's something in common here with the 5, the 60, and the 100. Those numbers, they work nicely together. And it seems like I can take out a 5, but not just a 5. If I notice that the negative, in fact, is also common, so I can take out the actual sign with the number. So I can take out negative 5. So if I take out negative 5 as a highest common factor, I have negative 5. If I open up the bracket, what remains, of course, if I divide negative 5 into the first term, I will be left with x to the power 2, or x squared. And if I divide negative 5 into the second term, I will have positive 60 divided by 5 is 12, I think. Yeah, 12x. And if I divide negative 5 into the third term, which is negative 100, I will have a positive 20, because 100 divided by 5 is 20. And at this point, some of you actually stopped. You took out a highest common factor, and part of these golden rules should actually be that once you have, if you have found that there is a highest common factor and you've taken it out, you are not done after you've checked, because the next step would be, can I factorize again? Can I factorize some more? Not can I take out another highest common factor, because if you've taken out the highest common factor, you've taken out the highest one. So you're not supposed to be able to take out one again, because if you can, it means that you didn't take out the highest common factor and you did it incorrectly. But let's say you did. You took out the highest common factor, which we did here. It was negative 5. Now the next step would be, after I factorized, because this is now factorized. Why? Because instead of having 3 terms like we had originally, I now have 1 term. That means it's factorized, because I've got negative 5 as a factor times this entire bracket as a factor. But the next question is, can I factorize some more? And I can, because I need to identify or recognize that in my bracket I have a trinomial. I can actually factorize some more. It's not taking out a highest common factor now, because that's been done, but I can possibly do one of the others. It's usually one of these guys. Okay, if I've taken out the highest common factor and there's still something left to do, that something left to do would either be one of the dots or the trinomial. So in our case, it's the trinomial. So let's look at how that would work. I keep my negative 5, and I know that the trinomial requires the 2 brackets. I will factorize my first term, and now I see, okay, I've got my, first of all, my coefficient here is 1, so this works nicely. It works nicely, and this trick only works when the coefficient is 1, in other words, the basic trinomials. I can see now that my third term is positive, so I know that my signs in my brackets must both be the same. Not both be positive, it must both be the same. It could be both negative or both positive. Now I need to go check, okay, what is my third term? Okay, my third term sign is positive, so whatever factors for 20 I choose, it needs to add up to a positive number here, a positive 12. Now if I look at my factors of 20, I've got 1 and 20, I've got 2 and 10, I've got 4 and 5, and I think that's it. Don't shoot me if I left out one. I think this is enough though, and it is very clear that this guy would be the one to pick, because they add up to 12. So if it is a positive number I'm looking for, and I know my third term is positive, I know both signs must be the same. and that same signs of course would be two pluses or two positive signs. And then it doesn't really matter where I put the 2 and the 10 because it's positive. That's the nice thing about positive numbers and addition. I can put the 2 there and the 10 there, or vice versa. And now I have still a factored trinomial. It's just that now I have, instead of having those 2 factors like I had originally, I now have 3 factors because this is now factorized fully. So I can still ask the question, can I factorize some more? And the answer here, of course, would be no, I am done. Okay, 3.3. I've already written it down here. If you can just see on the side of the page, that of course was 3.3 over there. And this was, again, the instruction remains factorize the following. So this is part of the following. So I have to factorize this. Now, if I go according to my hierarchy, I can clearly see that there is nothing in common between these two. There's no common factor. There's no highest common factor. I can't take out a 1. Okay, so please don't take out a 1 ever again. And if I look at the others, besides the 1, there's of course nothing that can be taken out here as a highest common factor. So this one is out. That one is out. So no highest common factor. So is it dots? Well, difference of 2 squares. I've got a difference. In other words, I've got a minus sign. I've got 2 terms. So it's difference of 2 stuff. But are these stuff squares? Well, 4 we know is a perfect square. And 8 to the power 2x is a perfect square, but perhaps not so obvious to everyone. So 8 to the power 2x, if I had to sort of just rewrite that a bit differently, 8 to the power 2x can be written as, so 8 to the power 2x can be written as 8 to the power x raised to the power 2. So 8 to the power x squared is a square number, and we know variables that are perfect squares are all the variables, all the powers that have even exponents, and of course 2 is an even exponent. So this simplifies of course to 2x, so it's the same thing. But the point here is 8 to the power 2x is a square, a perfect square. So that means that this is then the difference of 2 squares. So I know how to do that. Of course, I know that I need to open up 2 brackets once more. And I would then root the first term, which is 2, in 2. I can put in my plus minus. And if 8 to the power 2x is the square, then we know that 8 to the power x times 8 to the power x gives us 8 to the power 2x. So the root would be one of these guys. These are the roots. So it would be 8 to the power x and 8 to the power x. So there is 2 plus 8 to the power x and 2 minus 8 to the power x. Those are x's.